Okay, so what if everything you think you know about energy is, well, wrong? What if it's not some fundamental stuff that flows and changes, but something totally different? Today, we are diving deep into a really radical framework, one that redefines energy not as a substance, but as, get this, a form of cosmic bookkeeping.
All right, so here's how we're going to break this down. First, we'll tackle the central paradox of energy in a universe where time might not even exist. Then, we're going to see how this whole framework rethinks energy as just a calculation. We'll explore what it actually feels like to do something in a static reality. And then, this is the cool part, we'll uncover a simple rule that seems to govern everything from fusion reactors to food chains. And you bet we're going to look at some fascinating real-world proof to back it all up.
So let's just jump right into the heart of the problem, shall we? This whole framework kicks off with an idea that's pretty mind-bending. A universe where time, as we know it, doesn't really, well, flow. And if that's true, it creates a huge paradox with our everyday lives. I mean, really think about this for a second. We're taught that energy is the capacity to do work, right? And work happens over time. But what if time isn't what we think it is? This framework makes a really bold claim that our universe is a static, four-dimensional block where the past, the present, and the future all exist simultaneously. So the question becomes, what does it even mean to use energy in a world where everything has, in a very real sense, already happened?
Yeah, this is the paradox right here. I mean, you charge your phone, you put gas in your car, you feel the burn in your legs climbing a flight of stairs. Our entire lived experience is one of constant change, of energy being used and transferred. So how on earth do we square that very real, tangible experience with this idea of a static block universe where nothing is really in motion?
Okay, so the big question is, how do we solve this? The framework's answer requires a fundamental shift in how we think. It asks us to stop thinking of energy as a physical thing, a substance, and start seeing it as a mathematical tool. And to make sure we don't get confused, the framework neatly separates reality into three distinct layers. Think of it like this. First, you have the territory. That's the deep, true reality that we can never actually see directly. Then there's the map. That's what we can see. It's our scientific measurements, our observations. And finally, you have functionals. These are things like energy that we calculate based on our map. And here's the kicker. The framework claims energy doesn't even exist in the territory. It only exists in our calculations. So the main takeaway here is really profound. Energy isn't some physical thing floating around out there in the territory. Nope. It's a value we compute from our map, from the data we can actually measure. It's all about information, not substance. And this slide just lays out that shift perfectly. You've got the old view, where energy is like some kind of cosmic juice that flows around and gets transformed. But the new view? It's more like an entry in an accountant's ledger. It's just a number, a piece of bookkeeping that tells us the difference between one state on our map and another. Right, but if energy is just a number in some cosmic ledger, that brings us right back to our own experience. What's actually happening when we feel like we're doing something, like when a battery runs down? Well, the answer is actually pretty elegant. Picture the entire history of the universe as a movie already burned onto a Blu-ray disc. The whole story, beginning, middle, and end, is already there all at once. Our consciousness, our awareness, is like the laser that's reading the disc, frame by single frame, experiencing the story in sequence. They call this process foliation traversal. So that feeling of doing things isn't us changing the universe. It's just our awareness moving through this already complete static structure. And this concept, foliation traversal, is really the key that unlocks this whole thing. See, in this view, change isn't the universe evolving or happening in real time. It's just our perspective shifting from one slice of reality to the next. The fully charged battery and the dead battery, they both just exist as static slices in this 4D structure. Using the battery is simply our consciousness traveling from the charged slice to the dead one. Okay, but this new way of thinking does more than just solve a weird paradox. It actually gives us a really powerful new tool for predicting how systems will behave. And it all boils down to one single, surprisingly simple rule. They call it the gradient criterion, but we can just call it the singularity dominance rule. It's pretty straightforward. Now, a singularity here just means a source of influence. Think of the sun's gravity or a predator in an ecosystem. The rule is this. When one source of influence is way, way stronger than all the others, the system is stable and predictable. But when you have a bunch of different sources all competing and interfering with each other, the system descends into chaos. So let's put this into practice. You've got your high gradient systems. A perfect example is a planet orbiting a star. The star's gravity is the one big boss, the dominant force. The result? A nice, stable, predictable orbit. Then you have low gradient systems. Think about the inside of a turbulent plasma cloud. You have billions of particles all pushing and pulling on each other. There's no single boss, no dominant force, and the result is, well, chaos. And this isn't just some abstract physics concept. The framework claims this one rule can explain why some of our biggest energy projects are so incredibly hard, and at the same time, why the natural world around us can be so surprisingly stable. Let's put it to the test with two totally different systems, a fusion reactor and a simple food chain. Why is one so hard and the other, well, not? A fusion reactor is the ultimate low-gradient system. You've got countless particles all interfering with each other, creating massive instability. That's exactly why it's so difficult to control. But a food chain? That's a classic high-gradient system. There's a clear, stable hierarchy of dominant sources. The sun powers the plants feed the herbivores, and so on. It's predictable. All right, so it's a really compelling theory, and it seems to explain a lot. But you've got to ask, where's the proof? Is there any hard evidence? Well, according to the source material, the proof is hiding in plain sight in over a century of data on predator-prey cycles. First up, let's look at a classic data set, the Hudson's Bay Company records of lynx and snowshoe hare populations. For almost 100 years, this ecosystem was pretty isolated. You had one dominant predator, the lynx, and one dominant prey, the hare. It was a high-gradient system. And what do you see in the data? Just what the theory predicts. A clean, stable, predictable cycle of booms and busts. Okay, now let's compare that to the story of the wolves and moose on Isle Royale. This system was anything but isolated. It was constantly being hit by outside disruptions, new diseases, brutal winters, animals wandering in and out. Each one of those events acted as an interfering source, messing up the simple predator-prey dynamic. And what happened? Again, just what the theory predicts for a low-gradient system. The nice, clean cycle breaks down into a chaotic, unpredictable mess. And looking at these two side by side, you can really see the theory in action. On the left, you have that clean, stable lynx-hare cycle, a perfect example of a high-gradient system. And on the right, you have the chaotic wolf-moose data, showing exactly what happens when external forces push a system into a messy, low-gradient, interference-driven state. So the crucial point here is that both sets of data actually support the theory, just in different ways. The lynx-hare data shows that stable, predictable pattern of what they call singularity alternation. First, the prey population explodes, then the predator population follows. The wolf-moose data, on the other hand, shows what's called singularity invasion. That's the predicted chaos that happens when outside interference breaks that clean back-and-forth pattern. All right, let's just quickly recap the big ideas here. Number 1, energy isn't physical stuff, it's a calculation. Number 2, our feeling of using energy is actually just our consciousness taking a journey through a static, pre-existing reality. And number 3, one simple rule about dominant forces seems to explain stability and chaos in completely different systems, from fusion reactors to food chains. And most importantly, this isn't just a thought experiment. It makes predictions that seem to be confirmed by real-world data. And all of this leaves us with one last, pretty mind-bending question to chew on. If energy, which we think of as the very currency of change in our universe, is really just a mathematical concept, does that mean the ultimate laws of reality aren't physical at all? Are they mathematical? What would it really mean for us to be living inside a giant calculation?